Hello, welcome to Web App Wednesday. I am Tiberius, and we are going to be having some fun, fingers crossed, hacking some JWTs, JSON Web Tokens. There's a new, relatively new lab on Portswigger Web Academy that I have not really looked at. Because I figured it would make a good stream. But anyway, how is everybody? I see we've got a few people in chat. Always good. Ernesto425, first time chat. Welcome, welcome. Kettlebear, Ghost of Spooky, not famous. Interpreter Session was in here literally about 5 seconds after I went live. Always appreciated. Sparwall, Jester Juco. Portswigger, yes. Portswigger make Burp Suite. And they also have free web challenges. Really good. It's a really good platform. It's honestly the best platform for web security right now. Zero Kieran, hey. Dark Elder, happy Wednesday. Anita A, first time tuning in. Well, welcome to the stream. Thank you so much for joining us. That guy Kim, good to see you again. All right. Well, I figure I should probably start off with a few things. We'll start off with I'll get Stream Raiders going. We can try and continue this. Let me see. There we go. Alright, so for those of you who don't know, Stream Raiders is a game that we play every half an hour, or to be honest, it's supposed to be every half an hour. It's more likely every half an hour plus the time it takes for either chat to remind me we have a game, or for me to realize that we have a game. All you have to do is head over to the link in chat right now, sign in with your Twitch account every 5 minutes. If your browser volume is up, you'll hear I don't know, it's some kind of notification. You get to place a unit on the battlefield, and then in 30 minutes there'll be a battle where you don't control anything. Neither do I, to be honest with you. Right, so I figure next thing we'll do, just because it's slightly early in the stream, why don't we play Marbles? Another game. Marbles is another game we play. Again, 0 player. Although chat, should we do arcade mode again? I feel like boost mode was kind of crazy last time. So you know what, we did straight complex. Guess we could try straight clean. That sounds kind of boring. Maybe curvy complex. So yeah, we'll do that. All right, here we go. So, Marbles is usually a game where you don't control anything. It's all physics-based. You do exclamation point play to play. However, in arcade mode, if you type exclamation point boost followed by a number, I think it's between 0 and 600, you give your marble a little boost. Now, Giveram, granted, I did suggest to Al. I was on the stream and he was like, we're going to do some giveaways. And I'm like, do a giveaway with marbles. And I got him to install it. So, to be fair, I was there and I did grant him permission. And also, I feel like, you know, why not share the marble love, you know? I technically introduced it to InfoSec streaming. Then Gar7 started doing it. Because it's a fun game. I mean, it's hilarious. So I don't really mind. It's good to keep chat entertained. You know, between certain things, and to relieve the monotony. Sometimes it's really difficult just doing a box for 3 hours straight. All right, I'll give you 60 seconds. I'm going to actually join as well. I'm not going to boost though. So yeah, exclamation point play, and then once you're in the game, an exclamation point boost, followed by a number. I think it's 0 to 600. Someone can probably correct me on that. That will give your marble a boost, which might be good. Although if you boost straight into a curve, you're probably going to go off the edge. So let's see. 1 to 650? Yeah, I mean, try it out. Okay. 20 seconds. And we shall see 22 people so far. Okay. Where is everybody? There they all are. Alright. Okay, and they're off into what? Okay, this is I wouldn't use your boosts here. It's like a really bad place to use boosts. Agent OP seems to be in first place, followed by Kev XB and Fox Lord. Goes to Spooky coming up. Who is first down the pipe? It looks like Helleran, actually. But Fox Lord took the quicker pipe. So Fox Lord is currently in first, followed by myself somehow. Again, I'm not using boosts. Well, somebody's using boosts in there. I'm not sure it's a good idea. I'm going to try and keep an overview of everybody. Well, KevXB definitely used a boost. Foxlord still in first place. Nefarious probably used a boost. So did that guy Kim. Or they're just really unlucky. Alright, I'm going to go down here. So we have Foxlord followed by Helleran, Highcat PL, myself, Rickard. Bunch of people all the way back there. You should probably start using your boosts if you're over there. Alright, Foxlord. It's taken the left path. Is Helleran going to do the same? Yes. What about Rickard? Yes. But me and Highcat decided to take the right path. We are righties, okay. Oh, it looks like Helleran, though, has overtaken. The Foxlord is still all the way back there. Helleran is going... Hattensek just jumped off the edge. Helleran still going well. I'm going to follow him. Try and keep my eyes on everybody else. Okay, still good, but Foxlord has taken the lead again. Agent OP fell off the edge of the world. Between Foxlord and Helleran, it's very close. Where's the ending? Down there. Oh, Foxlord made it through. Goes to Spooky. Also looks like he made it through. But Foxlord comes in first, followed by Ghost of Spooky and Helleran. Kettlebear? You were all the way back. You must have boosted. Kettlebear and Who Is Sin? Looks like Who Is Sin. Oh no! That was the wrong time to boost Who Is Sin. Straight off the edge. Rickard, not Zero Famous. Okay, who's in last place? Well, it's basically a cluster of people. Looks like Highcat, no, now Morpheus. Here we go. Morpheus just overtakes, though. Alright. Oh, a lot of people didn't finish. Well done, Foxlord. Foxlord had it from the start. Alright. Cool. I didn't pay attention to any of chat, so I think, yeah, there was a lot of boosting going on. Who Is Sin had a late boost. Yeah, that was funny. Alright, okay, did I miss any...
New subscription received. Dispensing gratitude.
Virtual Tack, thank you for the tier 1 sub. Okay. We'll give you a spin in a minute. Giffaram, thought I was done with
New subscription
bots.
received.
Buffer
Dispensing
overflows.
gratitude.
Then I got to fixing exploits and had to mess with C exploit script. That was painful. I ended up using Python. Python's just really good. Breaksec, thank you very much for the Prime subscription. Okay, so we have 2 spins. Now, chat, I forgot to play the chess game at the end of the stream last time. Somebody won it on a spin. So we're going to have to do that. Someone's going to have to remind me to do that. So hang on a minute. So for those of you who don't know what's going on,
New
every time...
subscription received.
Here we go.
Gratitude. Gratitude dispensed.
Hat and Sec, thank you very much for the Prime subscription on a 2-month streak. Awesome. So those of you who don't know, if you subscribe using Prime or, you know, regular subscriptions, you get a spin on this lovely wheel. Okay, I'm going to give Ghost of Spooky a spin as well because, you know, that's fine. That was good. All right. I don't usually give spins for bits, but I'll make an exception this time. All right, so we got 4 spins. We got Virtual Attack, Break Sec, Hat and Sec, and Ghost of Spooky. Yeah. So if you want to spin, you either subscribe or wait for someone to subscribe. There's various things that happen on the wheel. Some of them are good for me. Some of them are great for you. This one's pretty good for me. Remove a category.
Dispensing gratitude.
Onida,
Gratitude
this is your on your first stream here. We're actually about 10 minutes in, and you have decided to subscribe. Thank you so much. Okay, so Virtual Attack. Here's a better list, I guess, of the categories. Virtual Attack. What do you want to remove? Bear in mind, it won't be removed permanently. I just basically check it off here. So we could remove Kill My Terminal 2 times next spin, Zap Gang for rest of stream, which has never occurred, by the way. That would be really bad on this one. I'm not sure the labs are really completable without burp. Well, it's Virtual Attack's decision. So, yeah, you do chess game. Yeah, the chess game does take a while, doesn't it? We've got a few that I just can't do yet. I need to get another webcam for Pick a Lock. Happy to remove Fred. Okay, there we go. Yeah. Alright, chess is gone. For now. Alright, Break Sec. Here we go. Oh, well, there you go. Break Sec gets us a marble race. Fantastic. We will get to the web stuff at some point, but, you know, screw it. Hat and Sec next. Well, there we go. I have to hack without glasses for 5 minutes. Obviously, I'm not hacking right now, so I'm just going to write it down. It's going to be fun. Okay, Ghost of Spooky for his 69 bits. Oh, I should probably turn down the volume on that, actually. I always forget to do that. That's a bit better. Alright, Ghost of Spooky, you get to add a category. Now, you can either add a category back, or you can add a completely new category. Yeah, hack with my screen rotated hundreds. Yeah, that would be interesting. Ghost of Spooky, do you want to add that one? I'm not entirely sure how I do that. There must be a setting in Windows, right? Because obviously I'd have to rotate the actual visual screen. Okay. I'll put it as a 5. Hack upside down. For 5 min. Alright, we'll do that. Okay. Anita A, your spin. The last spin of this current round, and then we'll do a quick marble race again. Oh, we're so close to Zap Gang. Well, there you go. Anita A, you get to add another category. So just to remind people, everyone subscribed to my YouTube is currently gone. So is the 5 CompTIA questions, which is awful. Change stream title, reset box. Is Stream Raiders on? Yeah, it is. You type battle, you should be able to get it. There must be a way of flipping your screen upside down. If not, I could always actually, presumably, there's got to be a filter on this. No, maybe not. Oh, hang on, transform. Here we go. There we go. I mean, that doesn't work. This is fine for me. I still see the screen fine. Let's flip it vertical again. There we go. Alright, there's got to be a way on Windows to do it, but we'll figure it out. We'll figure it out. In the display settings, you can flip the display length. Okay. Display. Oh yeah. Okay. Yeah, I can. Okay, I can do that. Actually, I really don't want to try it right now, just in case. Onida, you don't have to. Just come up with a suggestion at some point. You talk amongst yourselves. Let's do a marble race. Before we start. Thank you very much for the hype train, by the way. The level 1 hype train going, always nice. Go to the race menu. So we won't do the boosts. We'll do a proper one. Race, random, bongo boogie. Sure, why not? Alright. Oh yeah, please. Right, yeah. Stream Raiders did update. I'm just refreshing it now. Alright, exclamation point play in chat if you want to race in the marble race. This one does not have boosting, so by all means type boost in chat. Just know that you're not doing shit. Alright, I'm gonna play as well. Alright. 6-second countdown. You know what I do love about Al's stream is that he still doesn't seem to figure out there's by default a 10-second countdown. So he always does 3, 2, 1, then starts a 10-second countdown. It just makes me chuckle. All right. 25-ish seconds to go. Got 27 people in the race, 10 more seconds. Exclamation point play. And here we go. Did I turn it off? There we go. Ah! Well, this is annoying. I can't actually control anything. I'm actually stuck on... Why can't I control anything here? Hang on. Yeah, literally it's not even taking my inputs. I mean, it's if I press escape, it's fine. Cursor is maybe it's tab. All right, there we go. For some reason, I guess I must have accidentally pressed tab. Where are we all? I don't see any of you. There you all are. All right. First day, new legs. Maternity session hiker. Here we go, right at the end. I caught you in time. That was okay. That was all right. Well done. All these people falling off the edge of the world here. Break sex. Sorry, Bono's tech. Who is Sin coming in last place again? Well, actually, no, you yeeted yourself again. Sorry about that. We'll do another one at some point. I guess when you press tab, you just lose all control. Did not know that. All right. Okay, so Anita A. If you have mentioned which category to add, let me know. Just like tag me in chat. If not, come up with something. Okay, so JWT Attacks is the latest learning path on Portswigger. We've done a lot of stuff with JWTs before. So what they are, pretty simply actually, and I like going to jwt.io for this. So this is a JWT. Honestly, I do say JWT token, even though I realize I shouldn't, and I am one of those person who refuses to say pin number. A JWT token is meaningless because a JWT literally means JSON Web Token. So a JSON Web Token is this. It is effectively what I mean. You can pretty much tell this looks like it's base 64. It's not technically base 64 encoded. It's an encoding called base 64 URL. The difference being that whereas regular base 64 payloads have padding in the they have padding as equal signs at the end. That's why sometimes you'll see 1 or 2 equal signs. It's just a padding, and that's simply because in base 64 you're taking an 8-bit value and you're effectively making it 6 bits. And obviously if you have 3 6-bit values, no, if you have 4 6-bit values, that makes 8, right? Divisible by 8. Yes, because 24 is divided by 6 and 8. But if it's not divisible by 8, then you need extra padding. I can probably actually... I've probably made a complete bastardization of that. But there's a better thing on Wikipedia to explain what it does. Right. So, an M, right? These are the 8 bits that make up an M in ASCII or UTF. And what happens is you have M, A, and N, which are 3 8-bit characters, and instead, or how you encode them is you only take the first 6 bits and encode that as a letter. You take the next 6 bits, encode that as a letter, next 6, etc. Right? So M, A, and N becomes T, W, F, U. The padding is where you have an instance like this. So this was the instance I was saying, right? If you have 3 8-bit characters, that's the same as 4 6-bit characters. In this case, if you have just an M and an A, 2 times 8 is 16, which is not divisible by 6. So you get 3 6-bit characters because 16 can take 16 can't take 6 that many times, but what happens is you take it once, twice, and then you have these 4 bits left over, which means you have to pad them to make up the extra 2 bits. And so you get TWE, because obviously this is the last character, plus a bit of padding. And the same goes if you just had an M. So an M is obviously 8 bits, which means you get 2 characters. The padding here, something of zeros, making up this character. But then you have all this space left over, and so you do 2 equal signs. If that makes sense. So that's why you'll only ever see 2 equals and 1 equal sign on a base 64 encoded string. So this is different. This doesn't use any padding whatsoever. This doesn't use any equal signs. So you can pretty much work out what they're supposed to be. But yeah, it doesn't use equal signs because this could potentially be in a URL, and obviously equal signs in a URL not usually recommended. So a JWT consists of a header, this bit, separated by periods, by the way. There's 3 sections: a header, the payload or the body, and then a signature. Okay? The header, when decoded, looks like this. Basically, they're all JSON objects, hence the name JWT, JSON Web Token. Why is that doing that? There we go. The header usually contains the algorithm name that's used and potentially a type. This is JWT, which is obvious. The payload usually contains the data that you want to send, and the signature is effectively signing that data with some value. And so these are really useful for authentication instead of cookies, because you can effectively get the web application to generate one of these with all the information you need to identify the user in the payload. So you could have the username, you could have their roles, for instance, you could have whether they need to change their password, all that public, right? Well, not necessarily public, but unencoded. Safe in the knowledge that because you've signed it with a secret value on the server, nobody should be able to change the contents of the payload. Okay. So this is used in modern day web applications for authentication. Does anyone know whether this is state-based or stateless? Was it state or stateless based authentication? I wonder. Take a guess. Who is Sin says state-based. Ghost of Spooky says stateless. Well, one of you's wrong. Yeah, the majority here is correct. This is stateless. So a good way to think about it in terms of state and stateless authentication is, what does the server need to keep track of? If you're using cookies, then the server needs to store that cookie value with some kind of user in the database, right? Because when a user sends a cookie, the server has to look up the cookie in the database, see if it's a valid session, also see, which user is associated with that cookie. Now I know which user is authenticated. So that's a state. It's basically, it's holding the state of the cookie, because it also tracks, if the cookie's expired. JWT, on the other hand, the advantage of it is you can store all that information in here. You can store the name of the person, right? If there's a user ID, you could store the user ID in there. The roles of that user can be stored in there. The expiration of the token can be stored in there. Because the server's already verified it, because the server's generated this token, everything about the user's session, including everything the application really needs to know about the user to handle authentication, is stored within the JWT. So all it needs to do is extract it, verify it, and make sure that that data is valid, effectively. It doesn't need to track any form of state, because when a user sends an expired token, if that token is valid, it's going to look at the expiration date in the payload and say, this token's expired, so I'm going to redirect you to the login page. So that's the advantage of JWT. It's less overhead on the server. Also, it looks cooler. Okay. If you can decode the signature, can you exploit it with your own payload? Exactly. So obviously, whenever you're dealing with signatures, if you know the secret, or if you can somehow bypass this, then yeah, you're kind of screwed. So the security of JWT is all effectively relies on this signature mechanism here and how the server verifies the signature and the JWT. So as we'll see in these labs, there's a lot of attacks against JWT. So we'll get going with them. So we'll start with the ones that I know, because there's a lot about JWT that I obviously know, having dealt with them for years. One thing I will mention here, and this is something that actually I only learned recently, and the only reason I did was because I came across it in a web app for the first time ever. So what we usually call a JWT here is actually just a standard. And there are two current ways of implementing this. This way, where the data in the payload is all public. And there's a second way where everything's encrypted. And so the standard way where everything is I wouldn't say public, but plain text, I guess, is called a JWS. And a JWE, JSON Web Encryption, is where everything's encrypted. And these are more of a pain in the ass, but, you know, still. So really the only difference between the two is this one is not encrypted and this one is. Obviously, there's different attacks you can perform against each. Yeah, JWE is not more common. No way. I first encountered it in a web app like a few months ago. JWS seems still to be how most things are done. So yeah. So I'm going to be learning a bit here because I haven't really performed many attacks against JWE, so this is going to be a learning experience for me as well. So let's go down. We'll do the first lab, which I'm sure most of you have seen me exploit a few times on this stream before. I don't even need to know all of this information really. JWT authentication bypass via unverified signature. So this is perhaps the simplest authentication bypass you can do with JWTs. Oh, okay. And before that, we will do Stream Raiders. Thank you, Kettle Bear. There you go. Look at that. Alright. Let's view the battlefield. Where are the enemies? Okay, I'm just gonna put them there. Zap time. No. Only if it lands on the wheel. But to be honest, there's an extension we're using in Burp Suite that makes all this much easier. So I really don't want to use Zap for this. I don't know how to do anything with JWTs and Zap. All right. Well, a bunch of us are destroying capitalism over here. There goes Morgan Stanley. Oh, there we go. Defund the police. There we go. All right. We defeated capitalism and defunded the police right at the same time. That guy came in GoPro Slowyo, who probably isn't here. Well done. Let's finish the chapter. We'll go this way. All right, Kettle Bear, another half an hour, please. I'm gonna put my rogue out. How about respin? But before it, both you and chat get to remove a category for that spin. We could just do a respin if you want. That might be a better one. Just respin, because obviously remove a category is still technically there. How do you feel about just respin? Cool. Right, respin. All right, we'll have that as a 5 as well. All right, cool. Where are we? Right. So I think we have to sign in with Wiener Pizza. So the username Wiener and Peter has a history in Burp for some reason. I really don't understand why, but they used to have a, as part of their crawler, it would put names in certain fields, and the default I think would be Peter Winter, but I believe before that it was Peter Wiener, which is just funny. All right, so we've logged in. So let's go back here. What I will do is add this to the scope so we don't get any yes, okay. And then we'll only show scope items. So we logged in. Okay, so in this case they are setting a JWT as a cookie. Someone asked about this on a stream, I think it was on Monday, about the best place to store JWTs. Because somebody said you shouldn't store them in local storage, but OWASP didn't say anything. And then another person suggested session storage, which is a bit better. The problem with local storage and session storage is that JavaScript can always access them. So obviously storing them as a cookie with the HTTP only flag makes sense. Except that if you're using JWT as a cookie, you're kind of defeating the purpose of using JWT almost. I did do some research into it because it was an interesting question. As far as I can tell, nobody agrees with each other on this. There are blog posts from security experts who say never store it in local storage or session storage. There are blog posts that say session storage is absolutely fine. There are blog posts that say local storage is absolutely fine. Realistically, if you are storing a JWT in local storage and session storage, yeah, it's accessible via JavaScript, but you're only risking that if you have XSS. These days, there are a few neat ways to sort of defeat XSS by using CSP headers. So it's kind of like, So really, I don't know. I don't think I'm going to start reporting it if I find it in the local security. I mean, maybe I'll do it as like an informational, like, hey, maybe put it in a cookie, but I still don't really agree with putting in a cookie. So, if we try and go to /admin, it's probably going to deny us. Admin interface only available if logged in as an administrator. Okay. So let's have a look at this JWT token. What we can do here, we can copy this token, take it across the Hackverse, which is the greatest extension in Burp Suite. Ignore the fact that it tried to decrypt it. If we do this, we highlight the entire JWT, we go over to decode, all the way over to here, we can do get header, paste the token again, and then we can do get payload. And then effectively what we've done, we've passed the JWT, we've just extracted the header, and here we've extracted the payload. So the header has an ID, a key ID. You don't really need to understand what that means. We'll learn about it later in the labs. The algorithm looks like RSA 256. So I mean, you can probably guess what the key ID points to. The issuer is Portswigger. The sub, being the subject, is Wiener, and the EXP, the expiry, is whatever this date is. So the other way we could have done this is go to this. I mean, don't do this on a real test because this is a website that's not owned by the company you're testing, presumably. There's probably nothing that actually steals the token, but don't do this. There are plenty of ways to analyze this stuff without pasting it into random websites. This is just nice to show. It basically does the exact same thing, right? We saw this before. Yeah, here we go. Be careful where you paste them. So effectively exactly the same stuff. Now, this is signed by RSA SHA-256. So could we change the sub to admin? Yes. The most basic, and I mean that literally, the most basic exploit against JWTs is when you take the care to sign the entire token. You're so good at signing it. Like when you log in, when we logged in here, we posted the login. The application was like, I'm gonna sign the shit out of this token, right? So nobody can change it. I'm so good at security. Perfect at that bit. Then when it gets to checking it, it doesn't fucking verify the signature. So all we have to do is change the subject. You're halfway there. You signed the thing and then you just forgot the whole point of signing it. So yeah, if we sign the token, and actually we can pretty much if we send this to a repeater. And then if I double click this bit. So another great thing about Burp Suite, you can see it over here, is the inspector. So I've just double clicked this payload. I mean, you could just selected it as well. Burp Suite has automatically detected, hey, this is base64 encoded. And because I'm in a repeater tab and I can edit this, I just have to edit it over here. So I'm going to type admin instead of wiener. Apply changes, and it does all of that in reverse. It does screw up a little bit because it thinks it's base 64 when it's not, but we just have to delete those two equal signs. And then presumably not solved. It's logged in as an administrator. Oh, maybe it's administrator though. That might be it. Apply that again. This time we didn't see. This is the thing with padding, right? There was no padding needed that time. Yeah, there we go. All right. So if I render this page now, you can see we bypassed the signature because they didn't even bother verifying it. This signature is still valid for the old JWT token. It's just not being checked at all. And you could probably almost like do something like this. You could probably remove that bit of the token and it would still work. You could basically remove probably almost all of the token and it would still work. Okay, so we need to, what I'm going to do is I'm going to put this in the actual cookie in the browser. Application, cookies. Put that in there, refresh this page, and we have to delete Carlos, and then we solve all that. Which information? Who is Sin? Alright, any questions about that? That's pretty much the most basic JWT exploit available. Oh, right. No, I wrote a plugin. Where is it? I wrote blank title. Which is a massive hack. I'm not entirely sure you're supposed to be able to do this, but yeah. It was quite easy. I just had to find the J-frame in the sea of objects that were available to me. So yeah. Yeah. I did that because I really didn't want to stream with my name up there. Okay. So that was that done. Right. Okay, this is another attack I think we've definitely shown on the stream before. This is the other really basic attack against JWT. Okay. So we'll sign in again. Presumably Wiener Pizza again. Okay, So we're in as Wiener Pizza. I don't know which... I think this might be Joseph that flags this, or it might be JWT editor keys. Effectively, when it figures out you're using JWT tokens, it will highlight it for you. Alright, so we do need to go to /admin again. And we get the same error as before. Let's go to JWT spec algorithms. So if you remember, if I double click this header, this has the algorithm in it, which is currently RSA 256. So the algorithm is effectively telling the application server when it parses the token which algorithm was used to sign the signature. Oh, sorry. Which algorithm was used to generate the signature by signing the payload, I should probably say. So in this case, it was RSA 256 using a key that has this identifier. Pretty simple. Other versions, there's an HMAC version, which is usually based on SHA. So it's effectively a password-based one, although the password can be quite long. But if we have a look maybe at the algorithms, I wonder if it's here. Yes, here we go. So you know when you're writing a standard and you shouldn't be writing a standard, or you include something that's just really dumb. Yeah, this is that for JWT. JWTs may also be created that do not provide integrity protection. Why? Who knows? Such a JWS is called an unsecured JWS. Yeah, no shit. An unsecured JWS uses the alg value none. This is like, if you've ever dealt with OpenSSL misconfigurations, there's like anonymous ciphers you can have for no reason. Yeah. So there is a none algorithm you can specify. And if you're a web app developer who is trying to, I don't know, code the verification of your signature itself, none doesn't mean not encrypted. None just means there's no signature. So if you think about how a web server could be coded to parse and verify this, the first thing you're going to do, if you're doing it insecurely, the first thing you do is parse the header, and the header tells you which algorithm to use, right? Now, realistically, if you're a server, you should know which algorithm to use to sign the JWT, because you signed it in the first place. I mean, most of the time you signed it in the first place. If you're using, third-party authentication, so if you're getting another server to generate the session token, the JWT, that would be where you potentially don't know which algorithm is used. Most of the time, you should know what this is. Either way, if you're just extracting the algorithm and not verifying that it's what you expect, right? You should probably expect, oh, it should probably be RSA, or oh, it should probably be an HMAC. Then you're not coding it very securely. So in this case, you could potentially put the algorithm set to none, and then all you do is you remove the signature and you keep the final period. So it looks like a really weird token. But sometimes that does indeed work. I mean, so the first thing we can obviously try here is the first thing we did, which was just change Wiener to administrator. Administrator. Apply changes. Send it. Doesn't work because they're verifying the signature here, and the signature does not match. However, if we go and change this to none and remove the percentage 3D, that's just an error and equal sign, and then take off the entire signature. Remember, we still keep the period at the end. And now we have access. Because technically this is perfectly valid. This is a valid payload, and this says, hey, don't use any algorithm to generate a signature, please. And also, here's your non-existent signature. There's a great tool called Joseph, because sometimes there'll be filters against none, specifically lowercase. So what Joseph does, if we send it, can we send it here? Yes. No, we can't. Okay. I don't know why I just did that. I think if I send it from here... No, okay. I'll show you how to do it anyway. Joseph works better when it's not in a cookie. If we just go to manual, paste the JWT in there, click load, go to signature exclusion, click load, and then it has these values. If you're doing this using the attacker tab, it's basically the same thing. It'll just automatically resend the request, and it'll substitute the algorithm for all of these in turn. However, if you're doing it manually, like we have to do, like for instance, if we do this algorithm, none, all caps, now this is a cookie, no, so now this is a JWT with the algorithm none, but in all caps here. This might work, we'll see. It doesn't. We can try it with perhaps none just capitalized. See if that works. It doesn't. So it looks like none with just a lowercase n works, and that's the only one that works. But if you are doing a real test, hang on. If you're doing a real test and none doesn't work like this, always try it with variations. Why is that not working now? Did I mess up? Oh, I didn't change it to administrator. Okay. Oh, hang on then. My bad. I didn't change this to administrator first. Probably should have done that. So hang on, let's just show that in JWT again. So in Joseph again. So let me do... Okay, so I'm going to change Wiener to administrator. Apply changes. Now I'm going to copy this token into Joseph. Paste it up here again. Load. Signature exclusion. Load. Let's just try the capitalization one. See if this works. No. Okay. So none capitalized doesn't work, but presumably none. Come on, let's just do it. Yeah, none lowercase does work. Okay. Did you hear about webcast proximity yet? I did not. When you're on an engagement, do you timestamp your findings and talk about all the methods you tried that failed? I don't timestamp my findings. Usually Burp Suite has a timestamp. I don't really mention the time I found them specifically. And we don't generally talk about the methods I tried that failed. It's too much to track. You could talk about so much stuff. I will if the test is really good. And I'm on a readout call and the customer wants it, I can tell them what they did really well. But I mean, since I'm actively writing a web app course, just the number of vulnerabilities that I could say, I tested this, you were fine. I tested this these different number of ways, you were fine against all of them. You'd be on the readout call for 2 hours. Alright, so let's set this cookie. This one works. Okay. Refresh. Delete Carlos. Poor Carlos. There we go. And we solve all that. Any questions about that? And again, that only exists because I don't even know why. If you're developing something, why would you even use this? Okay. Brute forcing keys. Okay, so we can do this one. This is one I think that may have been on a CTF a few months ago. I seem to recall. Yeah, I seem to recall there being a JWT attack using a weak key. But we'll see. So presumably this token that they're going to generate when we log in is going to be quote-unquote secure against the verification attack we did and the non-algorithm attack. Okay, so we go into burp and we have a look at the session token that was presented. If we double click on the header, so whenever you see, so previously we've seen RSA signed tokens. This one is HS256, which basically is HMAC SHA-256. You don't necessarily need to understand what an HMAC is. All you need to really know is that this is a key used for signing that is generated from a password. Okay? So there is, I shouldn't say password, it's just secret. There is some secret value they have used, which then generates the key, which then signs the payload. So there are a couple of ways you could go about doing this. They do give us a word list of common secrets, which I guess we can use. Let's just put it in downloads. How many are there in there? Only 3,000. So they suggest using Hashcat. I honestly wasn't aware Hashcat had this feature, which is kind of cool. There is another thing, which is JWT crack. I think it's this one. Maybe not. Yeah, this one written in C. So we'll do both. I've tended to use this one in the past. I'm just going to CD into Tools, Web. I don't have it right. No. Git clone. Okay, we should just do make. JWT crack. Lovely. Oh, hang on a minute. This one doesn't do word lists. There was one that does word lists. Maybe it was the Python one. Alright, we'll do this one. This looks relatively okay. Yes, this one's a brute force one. So this one you give it an alphabet, a max length, and it will just go through all the possible keys. So that is decent. I didn't mean to do that. Let's copy this. Get clone that one. JWT cat. So now pip install -r requirements. We'll use pip3 actually. Okay, Python 3, JWT cat -h. Okay. Okay, so the token is the last thing. We want attack mode word list, but I'm not entirely sure how it wants us to pass the word list. I guess we'll see. Yeah, I can increase the terminal font. Is that better? Okay. It'd help if you specified that somewhere. So we do downloads, JWT secrets list, then the token. There we go. A bit more? Sure. Do you usually have trouble seeing it, or are you on a phone or something? Because I usually have it at the previous size. Alright, so you see how quick that was? Private key found, secret one. So there are various ways we could sign the token again. I believe with JWT editor keys, I think you can define a new one. Let me double check. Signing JWTs, alright. Okay, so we do need to just add is this the password we want to add? I've never actually added a key to this extension before. I guess we just add a password. We'll do the battle in a minute. Yeah, because this has to... No, I don't like that. Okay, I'm going to try it as a symmetric key, I guess. Secret one. Bad key. Okay, we can't do that. Okay, I guess it must be a password. Okay. Modify JWT header and payload. Click sign. Okay, so we go to admin again here, and we'll send this to Peter. And if I do administrator again, then there should be sign. No signing keys have been added to the keys tab. These are all elliptic curve. Yeah, I'm not entirely sure how you use JW Editor. I mean, I guess I'll Google it. JW Editor HMAC key. Or HMAC secret. Da, 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 da. There are various ways to sign it, I guess. I'm not entirely sure how you would sign it using this extension. JWT Editor, BAP Store. Okay, here's a README. Yeah, it doesn't look like it actually... Oh no, hang on. Octet sequence. Okay. So, presumably... But where's the octet sequence? OCT. Really helpful. Is there a wiki? No. Symmetric. I mean, this, yeah, it can't be any of this, unfortunately. RSA key, no. Yeah, it's unfortunately not going to be any of these. If anyone knows how to do this in JWT Editor keys, be really useful, but for some reason it doesn't even look like I can do it. So there are various ways. We can just use JWT.io again. Oh yeah. Let's do Stream Raiders first. Actually, sorry, we can't use JWT.io. Wow, we lost. Alright, we lost big time. We'll go back to the start, I guess. Okay. Alright, so there is this site token.dev. Again, there's so many. There are tools you can use to sign them. But effectively, what we want to do is, I mean, firstly, I guess we just copy this into here. So this is going to give this algorithm all of this, the string, the signing key. We don't want to base 64 encode it. Maybe we do. Minimum size of 256. Oh, come on. Okay, so I guess I can't use that unless I can generate. Is there an HMAC?
Incoming raid.
Thank you, Zurix Jelly, for the raid. How was your stream? Alright, what was this? Was it SHA 256? It was SHA 256, so we can generate oh, come on. You know what? I think what's that thing I use? The GCHQ thing. Cyberchef. I think this has a JWT signing. It does, yeah. Should have probably used this. There we go, look at that. Alright. This is a neat way of doing it. So what did we do? We did find secret one, right? Yeah, exactly. GCHQ in the browser. Okay. So we can just sign this. I think actually you don't sign the base 64 encoded thing, you sign the decoded one. So I think, yeah, this should be it. I think. Let's just see. I mean, that's fine. Yeah, okay. I mean, hopefully this works. Let's see. Okay, send. There we go, that worked. Okay, so long way around, unfortunately, but for some reason I forgot that the Cyberchef can do that. So the steps were we pass the original token to JWT cat with a word list, pass it the word list. All this file is doing, by the way, is it's extracting the payload here. It's decoding the payload, and then it's signing it using an HMAC with one of the words from this word list, and then it checks whether it matches this, because it should always match that. Okay, so I think we should be able to now go to the inspect, go to application, cookies. refresh. We should be... No? Is it still loading? Okay. Guess that didn't work properly. Oh, for some reason I did not save any value as a cookie. Lovely. That should work. There we go. Delete colors. Okay, awesome. I'll probably keep a bunch of this open actually. Okay. So we just did that one. Bypass via JWK header injection. Okay, so this is where it gets into areas I don't think I've explored before. So this will be interesting to figure out. So this has, in the header, this JWK attribute, which itself has a number of things. It has the key type, has the value for E, the KID, and the value for N. So this is for generating a public key. Ideally, servers should only use a limited whitelist of public keys to verify JWT signatures. However, misconfigured servers sometimes use a key that's embedded in the JWT parameter. You exploit this behavior by signing a modified JWT using your own RSA private key, then embedding the matching public key into the JWT header. Okay, so we don't. Yeah, we'll use the JWT editor to do this one. So here it is. So we'll sign in again. Wiener and pizza. Go back to Burp Suite. Well, sorry, we'll try visiting admin again. And we're not. Okay, so in this case, yeah, we see it's just signed by RSA 256. It has a key ID there. So obviously we want to do this change again by changing this to administrator. But then what we want to do, delete that key. New RSA key. Generate a new RSA key, send a request containing a JWT to Burp and Pizza, blah blah blah. Okay. So I guess we can just generate a new 2048-bit key. Sign it. Alright, there we go. So that's just generated a new RSA key. And then if we go here to... So we've already modified the payload. If we now go to JSON Web Token, we should be able to do... Was it sign? Click attack, then select embedded JWK. Okay, so it's already been changed. Attack, embedded JWK. That's the sign. I mean, it's the only signing key we have. So there. So now what that's done is it's embedded all this information about the public key which we just used, including the way to generate it, and it's signed the payload using our public key. So now, presumably, yeah, we can get to the admin panel. So, any questions about that? Because that's honestly a new type of attack I've actually never seen before, so that's kind of interesting. But I understand how it works. Effectively, you can give your own type of key. So all we're doing here is we're effectively sending the public key along. I guess I should be sending part of the private key, to be honest, with the payload so that the server uses it to verify the signature. Which makes sense. Right, exactly. Yeah, so sorry, we are sending the public key because the private key is the one here that we use to sign. And obviously you don't want to send your private key. But we can send the public key, and if the server trusts that public key, it'll verify. Okay. Injecting self-signed JWTs via the JKU parameter. Instead of embedding public keys directly, some servers that use the JKU JWK set URL header parameter to reference a JWK set containing the key. When verifying the signature, the server fetches the relevant key from this URL. Okay. That seems interesting. Thanks, Redacted. Thanks for joining. Okay. Sign in again. So this has an exploit server, which if you've done the labs before, you'll know if it ever gives you an exploit server, you're kind of expected to use it. So let's go to admin. Get the admin, turn it to repeater. Okay, so a JWK set is a JSON object containing an array of JWKs representing different keys. Okay, so we'll copy this. New file. So let's go over to this key that we already used. Copy as JWK. So does that just... So we probably just need the information we have here. So we need the KTY. We need the E value. We need the KID. And we need N. So if I do this, and we just put one in there. Okay. And we host this on the exploit server. Where did it say it's usually stored at? We can probably put it at that, to be honest. Alright. So we've stored it there. And then we have a JKU parameter. So let me just Google how to use a JKU parameter. Alright, Jessica, thanks for stopping by. Come on. Alright, so a JKU is literally just that. Okay. So can we... I'm just need to set this to administrator. We need to sign it. Do that. But then what we'll do, because this KID should match the one we saved. Right, so now we just need the JKU. Right. So we'll add another thing here. JKU. Point to that. Okay. And send. Does that work? No. Did we get anything? Get an access lock too. It did look like it. It did get it. So it is getting it. Question is, why is it not working? What was the original? Okay, maybe we should keep the same KID. So what we'll do is we'll keep this as the KID, change it to that, and then we'll go back to our exploit server and we'll change the KID here. Store and send that. Oh. This one's a puzzler. Administrator should be fine. Can I change the... If I can just change that there. Just make sure. Send that. Oh. For some reason that worked. I don't know why. But all I did was I changed the ID here to the same KID. I may have been using the wrong value. It also put the JKU at the first, which may have been something. Either way, that seems to have worked. Does anyone not understand what we did there? So effectively, we hosted at this URL information about the public key that should be used to verify the the signature. And that all this information is obviously ours. And yeah, we used it to sign the token. And then if we just refresh, we should be logged in. Delete the user Carlos. Good. All right. Injecting self-signed JWTs via the KID parameter. So this one is also interesting. Is when the KID is a file, and you can use directory traversal to just select another file, including dev null. Signing the token with a base 64 encoded null byte will result in a valid signature. Let's see if we can get that one working. Should be interesting. After this one, maybe we'll do another marble race. Alright, so for this one, again, we're doing the same thing. Logging in as Wiener Peter and going to admin. So we can have our test case here. Sending this to repeater. Now, so realistically what we want to do, change this to administrator as we always do. Copy all of this, go into CyberChef, and then sign the token with a base 64 encoded null byte. Okay. So where's base 64? Well, I guess I can just... I can use Hackverter for this. If we open a new one. If I do percentage 00 and decode it using URL, we get a null byte. If I then base 64 encode that, that is apparently a null byte encoded. I don't know if this is going to work or not, but maybe. Okay. So we don't want the header because we need to still change the header. If we do this, and then in the header, if we try and do what it says here, dot dot slash, but go to dev null. So let's just try that. Let's just try a few dot dot slashes. Dev null. I'm not entirely sure this will work, but we should try it. No. I'm expecting that the signature is incorrect. Can you set variables? I wonder if I can just paste the freaking Null bite, honestly. That'd be probably something worth trying. So there's a null bite. Nope. Okay. JWT sign with null bite. I wonder if it's just AA. It probably isn't. I'm gonna try it anyway. We're getting on to the more tricky stuff. It's also possible that it isn't enough dot slashes, but no, or it's too many. Sometimes it doesn't like them. So I gotta figure out a way, when I check this message, to sign a JWT using a null byte as the secret. Pretty much. Well, I guess we could probably do JWT HMAC sign Python. Because if we can do it in Python, we can just write a little script to do it. Okay. Alright, so this should work then. So this script works apart from the fact that he didn't need to base 64 encode it. So let's try it. Sign, guess JWT sign with null.py. Undo that. Oops. Set paste. Delete the base 64 bit. Then it should just take. So if we want to do a null byte in Python, what's the easiest way to do a null byte? Just dash X. Yeah, okay. So we should be able to just do that. Okay, and now if we... Oh, this didn't... That might have been why as well. I don't know if I checked that, actually. Probably didn't. It doesn't matter either way. Alright, let's grab this. And we'll put it in here as our JWT to sign. Okay. 3 print JWT. For some reason they were using Python 2. Okay. So really all we need is this bit. Nope. Anyone see anything I'm doing wrong? I'm going to try taking out a few of those, although it really shouldn't matter.
New subscription received. Dispensing gratitude. Gratitude dispensed.
Malicus Maximus, thank you. Subscribed for 9 months. What should we name the baby? That's a good. It has to be a strong Roman name. I feel. Gaius, maybe. All right. Let's do Stream Raiders. And then we'll try and figure out what's going on with this, because I feel like we've done everything we should have done. We'll try one more thing. Hold on. Damionos Gifaram Uni Sumeragi 2. Well done. Okay, we'll go to the middle path. We'll try one more thing, and then we will go back to. We'll do a round of marbles. The thing we will try is using this with the first value, the signing key being this, because this is definitely a null byte. So if we do that, requires a key with a minimum size of 256. Well, that doesn't. I wonder if we just do an H. Yeah, can we just do an HMAC? So, where's HMAC? Okay, the key as hex would be that. Shard 256. Oh, here we go. I think. I don't know if that's right or not. I guess we'll see. So obviously that isn't base 64 encoded now. But can we... Basically just trying random crap until it works right now. Okay. So we obviously need this. So that is a valid, apparently, signature. We'll see. Let's double check. Administrator. Yep. Nope. Even if we do more. So the only other thing I can think of right now is if we copy this and sign that. And then but I don't want the output to be hex. No, that. Alright, we'll do marbles. Do marbles while we get frustrated about this. Okay. Pixels Raceway? Sure, why not? Okay, everybody. Oh, Manicas, I didn't give you a spin either. We'll give you a spin in a minute. Alright. Okay, so exclamation point play in chat if you want to join the game. It is a 0-player game, meaning you don't have to do anything. You just have to... you didn't miss your marbles. We're doing it right now. Yeah, you just have to type exclamation point play. It's a physics-based game. So, yeah, you just watch your marble run down the track. I will try to remember not to press tab and completely lose sight of all of the marbles this time. That would probably be helpful. I'm going to give you guys 60 seconds to join. And then we'll try and go back to this weird one. We're probably not even going to get around to the encrypted tokens today, but that at least gives us something to do perhaps next week. Exclamation point play in the chat. 20 seconds. Ten seconds. Oh, here you go. You'll get past these first. Alright. They are off. FDS sec right down. Is there a way to actually... I swear there is there a way to go up and down without... I don't know. Find the controls. No, probably not. Okay, we've missed some people. Me and Onida A are like in first place. Oh, the graphics, we just got completely stopped. Graphics going over these bumps. Well ahead, hits the boost pad. Looks like the Gua is catching up though. Graphics takes the outside into another boost. Straight into another bunch of wheels though. Just massively ahead on this track. Can you avoid these? No. Loses all the momentum. I can't even see looks like the GUA is... The GUA is all the way back there. Is there any reason to follow anybody other than graphics right now? Just miles ahead of the competition. Although, got stuck a little bit. But Perryman looks like he's catching up. Will he... Oh, here we go. The GUA caught up. But will he make it round? Perryman! Perryman, it must have hit the boost right there and just went straight through, taking the lead from graphics. The GUA in third. Myself in fourth. FTSec is just chilling. What are you doing, FTSec? You just... Alright, everyone's just going to pass you by. We'll just watch everybody just pass FTSec by. Oh! Interpreter session felt bad. Freed FTSec. Who is Sin? Rickard, Christie coming through. That was it. Thank you, Interpreter session, for not leaving FTSec completely stranded there. Okay. So back to this weird lab. Oh, hang on a minute. No, it is the KID. Yeah, I don't really understand. We've done everything it looks like we should have done. In the header, we have the KID going back to dev null. The algorithm is HMAC SHA-256. This has the administrator set as the subject. Is it still... Are the sessions still valid? Looks like it. And this signature, we've tried various ways of doing. The latest was using this Python code, which should sign it using a null byte. I mean, the only thing I can think of is maybe this was correct all along. The base64.b64 encode. Actually, no, we don't even need that. We know what a base64 encoded null byte looks like. It looks like AA equals equals. But, well, I mean, let's see if that even works. I guess we should probably send all of that. No, but let me just double check something. Oh no, it was... Yep. I'm kind of stuck here. We've done everything it says. Ah, hang on. If the server stores its verification keys in the database, the KID header parameter is also a potential vector for SQL injection attacks. Oh, no, but this is path traversal. This says path traversal. I'm gonna sneak a quick peek at the solution, just because. In this solution, we'll point the KID parameter to the standard file and sign the token with a null byte. Okay. Oh, okay. So what they did was they used this new RSA key. They just generated one, But then... What did they replace? Replace the generated value for the K property with a base encoded null byte. Where's the K property though? Hang on a minute. New symmetric key. Oh, I did RSA. Okay. New symmetric key. Generate. There we go. Alright. See, this is what I'm missing. Alright, and we probably want this to be the same. Actually, no, we don't really care, do we? Because this didn't have a KID. Okay. So now if we go this, sign using this one. We don't want to modify the header. There we go. So I don't know why. I'm not entirely sure what we were doing wrong with our other methods here, but I guess that works. I just haven't used JWT editor keys to do that. The solution was you click new symmetric key, click generate, and then you can just replace the key, the K value, with whatever you want base64 encoded. And in this case, we just wanted a null byte. And then you change the header to obviously point to dev null, change the sub to administrator, and then you just click sign. Select the signing key, which is this one. And crucially, don't modify header because we've already modified the header. We don't want to overwrite any of these. And that got us there. I'd honestly like to know how you do it without JWT editor keys, though. That would be interesting, but I guess that's something for another day. Okay, refresh, delete Carlos, and we solve the lab. I'm gonna go back, see exactly which labs we have solved. Okay, so we have solved all of the apprentice and practitioner ones. The next ones are expert, which honestly maybe expert on Web Academy is super tricky, and sometimes you can be there for hours trying to figure something out. Which is probably going to be how it is this time around. Algorithm confusion. So this is probably to do with encryption. Performing an algorithm confusion attack. Okay. Right, so I have heard of this attack before. Or something very much like it.
The year is 1991. Birds and people are living together in seemingly perfect harmony. Until one day, a young man catches fire. This is Phoenix.
So yeah, in this case, what you're doing is you're obtaining the public key somehow, and then obviously the public key is used in an RSA. signature verification. But if you use the public key to sign the JWT using the HMAC, because obviously you can't sign using a public key, you sign using the private key, which you don't have. But if you create a signature using the public key with an HMAC and use the public key as the secret, then it's potentially possible that the server will see the HMAC and use the public key as the signature, as the secret again. Well, the thing is that I need to take the exam, honestly. They say for the exam you just need really to have done all the practitioner level stuff, which I'm gradually working through. I don't think it's honestly too difficult to work through the practitioner things. I believe in the exam there's only 3 vulnerabilities you have to find. Obviously, I don't know how complicated they are. Are there a lot of bugs being reported in crypto stuff? It kind of depends. Stuff like this, not necessarily. A lot of the JWT attacks, a lot of JWT tokens are handled by libraries, which are generally, fingers crossed, secure against these kind of attacks. The problem with crypto is unless you have access to the source code, you don't really know what's happening with the crypto. So it really depends. Let's give this one a go. No promises, because it looks like there are several steps, including converting keys, which might be tricky. But let's at least give it a go. Where is it? I'm not familiar with that one. Okay, so Wiener Pizza again. Go to admin. Now it says the public key is exposed. A certain endpoint, so it's probably going to be that. It's probably going to be that .well-known endpoint, I guess. I'm trying to figure out. Trying to remember where we had it. I guess I missed it. There it is. I usually read up on, anything that makes it public, or on Twitter. I don't stay well versed of every single hack though. Okay, so there's nothing there. Maybe go to robots.txt. No. Okay. Let's view the page source, see if there's anything interesting in the page source. It's entirely possible that it's actually using the certificate, the public key in the certificate. So we could try that. This one, yeah. This one, sorry. View certificate. This by Amazon. Ooh, I don't know. No, because presumably this could potentially change. Alright, what was the thing on this again? Hang on. First obtain the server's public key. This is exposed for a standard endpoint. Which is making me think, you know, endpoint. So maybe something like key. I guess we just need to go hunting for it. I'm confused what it means by standard endpoint. Any ideas? Oh, I guess actually it might be in the... I should probably actually look at the token. No. Yeah. See, this is why these expert ones are super difficult. I could try the certificate. My problem with the certificate is this one is generated by Amazon. Like, it's not, it's issued by Amazon. I mean, I guess we could try it. We're gonna say the file. Where did it save to? WebSecurityAcademy.net. I will do the Rubik's Cube in a minute. OpenSSL. Most common OpenSSL commands is like a... This is a really good resource. I know about some crypto stuff. I wouldn't say I'm a crypto expert. Okay, I guess it's not on here. Extract public key from PEM. Oh, that kind of crypto. I own some Bitcoin. All right, this might work. We'll see. So web, and we'll do web security academy net. From cert pen. Okay, this one. Yeah, this one should work. Okay. Web security pen.
Incoming raid.
Breaksec, thank you so much for the raid. How was your stream? Okay, so this should be... Probably shouldn't cat it with caps lock. So this should be the public key. And I guess I should do... We'll do web hub.pem. Oops. Because we want it in different formats. Okay. Okay, let's do the Rubik's Cube. If I can find the Rubik's Cube, there it is. Webcam. Alright. I'll look away. Yes, it's scrambled enough, but I think everyone can agree that's pretty damn scrambled. Okay. Solve it. Should keep my hands in view. You see, why doesn't that sound effect happen when I'm on the regular screen? I need to fix that. GoPro, are you actually here or are you a bot? You didn't miss your spin. Actually, thank you for reminding me. We'll do that in a minute. Where are we? We're just doing a Rubik's Cube solve. Okay, almost there. Done. All right. All right, GoPro. Thank you for admitting you are a bot. Screen. Okay. Malicus, this is for your. This is for you and Gaius, little Gaius. Oh, you came so close to Zap Gang. I don't remember. I don't know which cube this is. This is just one I bought on Amazon. It's Japanese though, I think. Could be Japanese or Korean or even Chinese. No idea. All right, 2 times spin. So basically, whoever subscribes next Oh, I wasn't hacking that glass for 5 minutes. I should probably, actually do that. You guys need to keep me honest. All right, hang on. I'm gonna take my glasses off. Okay, I'll put a 5-minute timer on. This is going to be super interesting. So we need to do some conversions. I'm actually going to make directory keys. Me webpub into keys. All right, converting keys. I'm just going to Google convert public PEM to other formats. I think you can just do it in OpenSSL. Convert PEM formatted public key to DER. Okay, you can just do that. Can't see a damn thing. Alright, we'll see into keys. Alright, so this is the PEM file, and then we obviously want just to give it webpub.der. Okay. I'm just gonna vim. Okay. Assume that's fine. I don't think you can have a P12 without. Because P12 is a public key and private key, I thought. I guess we could just try it. I guess, we just do this. Webpub.pem. Again, no guarantees this is even going to work. Right, expecting any private key, and we didn't give it a private key. Guess RSA public key formats. So I know about DER. Does anyone know of another one? We've got PM, we've got DER, specifically for public keys. Do you think can we convert it to PGP? I doubt it would be PGP. RSA key formats. Here we go. So the certificate is everything. But we haven't got the private key, so we need... Okay, XML format. Interesting. Okay. OpenSSL. Convert hem to XML. Does it do that? Use the following online RSA converter tool, which obviously you should never fucking use. But there we go. Alright, I can actually put my glasses back on. Good. Alright. Never actually do this. Webpub hem. So we obviously need to copy all of this. Okay. That's the only ones I can think of. Or find. Okay. So the next step. Alright, so we can just do new symmetric key. Generate. And then the K value. Replace the generated value for the K parameter with a base 64 encoded PEM key that you just copied. So basically we need to take all of this. Actually, unless that's the base. Because that is base 64. Is that all they want? You know what? I'm going to do this. I'm going to click new RSA key. So I want to see what format they want. New RSA key. Generate. Okay, so they do want that. That's what I thought. New symmetric key. No. So we do need to copy this. And then base 64 encode it. Which we can do here. Okay. Use, do that, and then K there is this. Okay. All right, modify. So we'll do this. Amazingly, it timed out, because of course it did. I hope the freaking key didn't change. We should be able to quickly check if it changed or not. Actually, no, maybe not. Okay. If the certificates are identical, should be fine. Let's get all this crap. My account. Mina pizza. Alright. We go into here. Shard 2 by 6. Sum of both web So, good news, they're identical. Okay. We want to go to admin. Send this to repeater again. Make sure we get this. So we want to obviously change Wiener to add administrator. We also want to change this to HS256. I can change it, please. Why can't I change that? That's ridiculous. Well, now I can, apparently. HS256. We're going to take this KID and replace it with this one here. Okay, we're going to go JSON Web Token. Sign. Using that. Don't modify header. Send. Of course it didn't work. So the other thing we could do is base 64 encode web pub.der. We want to do -W0 to get all one line. And then go back to this and replace the K value here. With that, try signing it again. Again using this. Don't modify header. No. I'm pretty sure it's not going to be the XML version, but why not? If it's not this, we'll look up the solution because I'm kind of interested, but also I'm not entirely sure we even got the right key, to be honest with you, but I don't really know where they would expect it to be. Sign it again. This. Yeah, alright. Oh, actually, there's a hint here. Alright, that doesn't really help us because we already used the PM. Okay. It went to, so instead of the location it told us to go before, we have to go here. Alright, let's try this. Oops. So extract it. Okay, never mind. You can convert a JWK to a PM using this. Okay, so we can copy this thing here. Actually, I think we just copied this bit. Yeah. Okay. New RSA. New RSA, and then paste that. Yeah, we'll overwrite the key, that's fine. Okay, I mean, now we should just be able to easily do it, I think. Sign. Which one do we sign? Oh, hang on, that's not... Uh-oh, we need to copy the... Right. We need to go to PEM. Now we can copy this. Now we can go new symmetric key. No, what was it again? Base 64 encode it. Okay. This is actually a really neat attack. Alright, so now we base 64 encoded it. We can go new symmetric key. 250s. No. Oh, generate the key and then replace the... Right. Okay, we generate it. And then we go here. And replace that. Now we need to... we need to make sure we're using the right KID, which is this one here. I'm gonna... I think it's this one as well. I'm just gonna delete this one. I'm gonna delete... To be honest, I'm gonna delete all of them. And we're just gonna put the KID here. Okay. So this should all work if I now sign it using this key. Send? No. Oh boy. I don't really understand what we did wrong there. Algorithm is HS256. This looks fine. This begins in LS and ends in 0T. Alright. Copy the JWK object. Yeah, I mean, I did all this. I guess we'll just try it again from here, but... Try administrator. Apply changes. We want this one to be HS. Come on, why won't it? There we go. HS256. This is the KID. Apply. Double check the KID is there. Yup. JSON web token. Sign. H256. That key, don't modify header. Send. Anyone see what I'm doing wrong? Because I've literally followed their instructions. Unless I didn't do this bit properly, so we'll try that again. Okay, view page sources this. So what we need is, yeah, all of that. All the way to there. Okay, I'm going to clear out this key. New RSA key. Paste that in. This is the... So I guess the only other thing I could think of is we need to just take this instead. So what I'll do... We'll paste that there. Oops. But I really doubt that's what we need to do. Unless it's all of this. Maybe it's all of that. Maybe there's an extra bit. That could be it. Okay, new symmetric key, generate. Paste that in there. Okay. Back to repeater, grab the KID again. This one here. Okay. Sign. There we go, that was it. So the answer was there was actually a new line we needed. That was literally it. I wasn't doing a new line at the end, I was encoding all of that. If we'd done that, it would have worked the first time. Alright, any questions about that one? That actually puts us up to almost 3 hours, which is a nice place to stop. Any questions about any of this, to be honest with you? There we go. Okay. Let's start the battle, and we'll do one more marble game before we decide who to raid. We'll actually try and find someone now. Alright, we have a few people we could raid. Okay, well done. Well done, Lahenu. We'll do marbles one more time. Off the rails sounds fun. Alright. No questions about that one? Exclamation point play in chat if you want to play. Again, if you're new, this is a physics-based game. You don't have to do anything other than type exclamation point play. You'll be automatically entered in. Alright, I'll give you guys 60 seconds. You can still join within those 60 seconds. Exclamation point play. Always fun. So, we'll raid either Security Weekly or Security FWD. On Friday, we are going, if the plan, if it goes to plan, we will finish the Matrix Exit Denied box from Try Hack Me. It's a hard box. We didn't even technically get shell on. We got quite far. There were a bunch of stuff pre-shell that we got. But yeah, we will hopefully finish that and root that box. Oh, this has an interesting start like the previous one. Alright. And they are off. Looks like Rickard and Perryman were first down. Ooh, this looks interesting. Okay. Damien, the first down to the bottom. And off, actually, myself. There we go. Alright, everybody looks like they're out. Maybe? Nope, Perryman's still inside. There he is, out. Okay. Alright. Who is taking a unique path? So far, me, Alhaj Banu. Pretty much just us. Alright, around Spinnies. Compendium is just lagging behind. We're just gonna ignore him. Okay, Alhaj Banu looks like he got the advantage there. Rushing ahead. Everyone else is still on this bit. Oh, I came out there, but yeah, Alhaj Banu is still just in first place. We're actually going to follow and see what happens. Oh, got stopped by the weird spinny thing. And Manicus just straight through. Look at that. Rickard close behind. Oh, but Manicus bounces against the wall. So does Rickard. Who is going to get down? Nefarious coming up from behind me. Just overtaking everybody. And falling to our deaths. Okay, fun. Nefarious now. Can Nefarious... Oh no, Rickard somehow made it in. I don't understand that. Nefarious... Compendium died. Particle de Dieu. Alhaj Banu died. Okay, Perryman is in technically 5th place. All the way back here. You got 38 seconds to complete. He hits a wall. Will he make it in? Drops down into the runway here. Okay, this is the tricky bit. Looking good so far. And in. Okay, that was a good one. I love that the first 3 of us just fell off. Completely. Well done, Rickard. Oh, there are only 4 people. Wow. Okay. Thank you so much. I will put the stream ending. We will... let's go to Security FWD. Because they haven't even been streaming an hour, I think. So we'll see what they are doing. On the screen are my socials. Please follow me on Twitter. Join the Discord server. Subscribe to my YouTube channel. And give me a follow on Twitch. So you can get notified when I go live. Thank you so much for joining me today on Wednesday. I hope everybody learned a bunch about JWTs. We'll be there hopefully on Frustration Friday to complete the Matrix box on Try Hack Me. But otherwise, I hope everyone has a great rest of the week. And I will see you on Friday.